Hello and welcome to Nurture Academy. Today in this module we are going to learn about parabolic motion. Whenever a body travels in a parabolic path, I have drawn a nice graph for you guys. You can notice on the graph this line is x-axis and this line is y-axis. Now when a projectile is at this position, now we can break into two coordinates, that is 100 and 200. Or I can also say that it is 100 in x-axis and 200 meters in y-axis. Or I can say the coordinates as 100 I cap and 200 j cap. Means on and all, what I want to say is that when a body travels in a projectile motion, then each and every point on the path can be denoted in two different distances. X-axis distance with I cap, y-axis distance with j cap. Okay, but now we will be usually given velocity in terms of some vector, let's say a vector. In that case, it will be very difficult to figure out x-axis component and y-axis component. Then we will just divide into a cos theta and a sin theta. Whenever a projectile makes an angle theta with any of the axis, it doesn't need to be mandatory x-axis, but in this case I am taking theta is the angle which the a vector is making with x-axis. So this is a cos theta component and perpendicular to a cos theta would be my a sin theta component. Now let us derive the expression for motion of a projectile. So looking at any equation, how do I know that this type of path followed is a projectile? So whenever we are going in a projectile motion, let us say our initial speed is u. Initial speed is always denoted as u. I resolve the vector into u cos theta and u sin theta component. Remember, I broke down all the distances into x-axis distance and y-axis distance. Now the thing is that when a body moves in projectile motion like a aeroplane or something, then the acceleration in x-axis would be equal to 0 and acceleration in y-axis would be equal to minus g, minus of the acceleration due to gravity. Why minus? Because it is going in the opposite direction than gravity. After that it is simple. Ux we have already told, it is u cos theta. Uy is the y-axis component of initial velocity, that is u sin theta. Then to find the distance travel in x-axis, I will use simple formula which is equivalent to S is equal to ut plus half at square. Simple. Just fill the value of ux, just fill the value of ax. We will get x is equal to u cos theta divided by t. So time period for traveling in x-axis would be x divided by u cos theta. Same way we can find final velocity in x-axis. So that will come equal to the initial velocity in x-axis, that is u cos theta. Now same way we can find final velocity in the y-axis. Final velocity in y-axis we will use a formula v is equal to u plus at. Now uy, you know the value, it is u sin theta. Ay, we know the value, it is minus g. So Vy would be equal to u sin theta minus gt. Now what we will do is we will try to find the equation of the path of a projectile. So this is the equation. I use the expression when a parabola goes only in y direction. Let us say, we can say y is equal to ut plus half at square. Simple equation. Fill the value of uy, fill the value of ay. Instead of t, I use the value of t from this expression because I don't want t in my expression, instead I want x. And I get the equation of trajectory of a parabola, that is y is equal to tangent theta into x minus half g x square upon u square cos square theta. Whenever you come across such type of equation of motion, that means that this type of body is following a projectile motion. Let us try to understand one problem based upon the trajectory of the parabolic motion. In this question, a boy is standing on a beach. He is playing with his sister and the sister is standing 6 meters away from this guy. Sister is sitting on a cliff which is 3 meters in height. Now this guy throw an apple towards his sister with the initial speed of 10 meters per second. We have to find the angle at which he should throw so that the sister is able to catch it. So I write the given data. Initial speed of throw 10 meters per second. Distance in y-axis 3 meters. Distance in x-axis 6 meters. Theta I have to find out. I will use simple equation of trajectory of parabola since I know that it will follow parabolic path. So I will write the equation y equal to x tangent theta minus gx square upon 2u square cos of theta. Simply fill the values. Okay. Instead of cos theta, when you take cos theta up, then it becomes secant square theta. Cos square theta inverse is secant square theta. And then we should know there is one trigonometric relation, that is secant square theta is equal to 1 plus tangent square theta. So this value I will use and then ultimately I will get this expression. When I solve this expression, it's a quadratic equation. I can solve it easily and I'll find the root of the quadratic equation. There can be two value of theta when this boy can throw the apple and his sister would be able to catch. So what I am trying to say with this example is that it is very easy to solve this kind of numerical problems if we know that if this type of motion follows the parabolic motion path. Let us try to calculate the time to reach the maximum height. Maximum height means when the projectile reach at this point. That time we have to remember that velocity in y-axis would be equal to 0 because it cannot travel in this direction, it has to go now down. So using this equation v is equal to u plus at, I can find the time to reach the maximum height. It will come u sin theta upon j. So this is the time taken to reach to the maximum height. Now you can see by symmetry that this is half of the time taken for the full flight. That is why if we want to calculate time for full flight, that will be 2 times time taken to reach the maximum height and it will be 2u sin theta divided by g. Next task is I have to calculate the maximum height. I want to calculate this distance for parabola to reach to the maximum height. When we are talking about maximum height, we are talking only about the distance traveled in y-axis. So I'll use again equation of y-axis. This whole parabolic portion is about breaking the components, x component and y component of the motion. Again I use the equation y is equal to ut plus half at square. Fill the value. This time the value of t I will use from the time taken to reach the maximum height. Remember we are calculating maximum height. So value of t would be the time taken to reach maximum height, that is u sin theta divided by g. When you fill this value for time here and here, you will get final answer for maximum height as u square sin square theta upon 2g. This expression you can also write as h is equal to u square sin square theta upon 2g. Next is we have to calculate the maximum horizontal range. Maximum horizontal range means this distance r when a parabola starts from here and it lands here. Maximum horizontal distance. So as you know, this distance is only in x-axis. So I will use the equation of x-axis. S is equal to ut plus half at square again. Ax is equal to 0. Okay. In this case, I have to take time period as time of flight, not time for reaching the maximum height. So when I fill the value, I will finally get the equation of range as u square sin 2 theta upon g. This expression is trigonometric expression, that is sin 2 theta can be written as 2 sin theta cos theta. So same expression can be written as 2u square cos theta sin theta upon g. Sometimes to solve numerical problem this expression is easy, sometimes to solve numerical problem this expression is easy. So you choose whichever is easy for you guys. Next is, there is one numerical problem in which they have given initial velocity of a parabola in the form of vector xi cap plus y j cap. Okay, and they have also given that maximum height of a parabola is twice that of the range of the parabola, and we have to find the value of y by x. Whenever you are given any numerical in which we are given range, we are given height. First task, you write the formula for range, you write the formula for height. And now what you do is you try to see these formulas are actually very similar to each other. In the formula of height I am having one sine extra. In the formula of range I am having one cos extra. Just keep it in mind. For this particular question we just fill the value r is equal to 2 times h because it's already given that range is 2 times that of the height. So when I fill the value, okay, I come to this much part, 2u square sin theta cos theta is equal to u sin theta into u sin theta. I just wrote it smartly, u square sin square theta is u sin theta and u sin theta. We already know that y-axis component is always written as u sin theta, and x-axis component is also always written as u cos theta. Again and again what we are doing is we are resolving the vector into two components, u cos theta and u sin theta. That is very easy. So then after filling the value here, where I see u sin theta I put y, where I see u cos theta I put x. So I will get 2yx is equal to y square. And then y and y cancel. Ultimately I found the value of y by x equal to 2. In another variation of this type of question is they will ask you to find the angle. When they will give you range, they will give you height. So you should know, remember I told you there is one extra cos theta here, there is one extra sin theta here, and you should know trigonometric function sin theta divided by cos theta is equal to tangent theta. That means if I have to find the angle, I can always try h divided by r. Whenever I do h by r, I will be left with tangent of theta, so I can comfortably calculate the value of angle of projection of a parabola. Last numerical is the application of parabolic path in day-to-day life. So what is happening? Two people are playing the game of tennis. This guy is serving the ball horizontally but from a distance of 2 meters. This is the net. Net is 0.9 meter high. We know that when we serve the ball, it has to cross the net smoothly. It should not touch the net, right? And the net is given at a 12 meter distance. So the first part of the question is that you have to calculate the minimum initial velocity with which this guy should serve so that the ball will clear the net, which is 0.9 meter high and it is 12 meter away. So what we will do is, that means the velocity should be more than the minimum velocity and the distance travel is only in the x direction. So we will use the expression x is equal to ut plus half axt square. In this one, what you do is you don't break the component into u cos theta and u sin theta. Just keep it as u. So you will get x is equal to u into t. From here you got the value of t as x by u. Now you consider y-axis motion for the same shuttlecock or the ball. You will get y is equal to uyt minus half gt square. Again ignore sin theta component and just write it as u into t value you fill from here. You will get u into x by u minus this whole thing. Okay. Ultimately you will be left with this equation, y is equal to x minus half gt square. Okay. So you are left only with the u component. you are only left with x-axis component, you are only left with y-axis component. We know x-axis distance has to be 12 meter. We know y-axis distance has to be 0.9 meter. So using this, we can smartly calculate the minimum initial velocity. And obviously, you have to hit more than that initial velocity if you want the ball to clear the net without hitting it. Okay, this is first part of the question. For second part of the question is that this guy has to serve the ball so that the ball should go and hit the ground, which is 18 meter away from the server. Okay, now it has to go and it has to not go out of the court, otherwise there will be a goal. That is the basic idea. It's a day-to-day life problem. In this, we will use one smart thing. Usually parabola, what we do is we shoot it from the ground, not from some height. In this case, this guy is standing at 2 meter height. So how about what I do is I make x-axis as 0 because I want, general expression for parabola, and instead that 2 meter what was there, I will consider it in the y-axis distance. Okay, since the ball has to go from here and it has to come back and hit the ground, right, which is 18 meter away. So when it hits the ground, that time the y-axis distance will be uy would be equal to 0. Y-axis distance would be equal to 0, and I have added that 2 meter which this guy was standing into y-axis. So I will get 0 plus y is equal to minus half gt square, because in this case my uy is also equal to 0. There is no initial speed in the y-axis. Okay, so I will get the value of time. When I got the value of time, then I can simply fill it into this expression. Okay, ut is equal to 18 because again y is equal to ut plus half gt square, and I will get what should be the minimum velocity by which this guy should hit so that it reaches 18 meter height. If you are uncomfortable with this method, you can as well try the same way as we have done part number 1. You will get the same answer. So hope you like the video. For many more videos like that, please like, subscribe and share our channel, and if you have any question, please tell us in the comment box. Thank you.